Assalamu alaikum. We have a question on continuous motion in dynamics about a particle moving along a straight line. Let us read the question. The position of a particle along a straight line is given this formula, is equal 1.5 t cubed minus 13.5 t squared plus 22.5 t feet. Now, t here is in seconds. The question says determine the position of the particle when t equals 6 seconds and the total distance it travels during the 6-time interval. Also, they give us here a hint. Plot the path to determine the total distance traveled. I'll solve this question two ways. The first method here will work for this question, but if we have, big numbers, it might start to get a little bit tricky. But now, what we will do now here, the first part here, determine the position, okay, when t is 6 seconds. So simply I'm going to just replace t by 6 in the S formula or equation. So S here at 6, right, will be now, just do this in the calculator. Okay, so I got minus 27 feet. Okay, so that's now my distance at 6. Right, let us think now about this. What if we now substitute this with 0? Now, if you replace this with 0, now you will get 0, right? So it means now this particle here, if we now try to make a diagram, okay, or a line, and here I'll say that's my point 0. So it means the particle now, at some point, went to this direction, to the left. So how do we know when the particle changes direction? Now, as I said, I'll solve this question two ways. The first method here, I'm just going simply to replace uh, t until I reach 6. So now I'll find what is the position at 1, okay, what is the position at 2, what is the position at 3, what is the position and also 4 and 5. Okay, 5. Okay, let us do that. At 1 here, if I replace t by 1, I'll get 10.5 feet. At 2, I got 3 feet. At 3 seconds, I got negative 13.5 feet. At 4 seconds, I got negative 30 feet. And at 5 seconds, I got uh, negative 37.5 feet. And at 6, or you already got that number. Okay. So now let's look at the sign here. The sign, we start from 0, right? Then it's positive, positive, negative, negative, and so on. Now it means now the particle changes direction. Let me now try to plot the path of this particle, starting from 0. Okay, now start from 0, I will go to the 1 second. After 1 second now, I am somewhere here. Okay, so now I am at 10.5 feet, right? At 2 seconds now see what happens. At 2 seconds, the particle in fact goes back. So now I can say now I'm going here, then after some time, the particle just took a turn. And now it is here. Right? So that's 3. So now we start to be here, then now we went back to this position. Right. Sorry. So now at 3 seconds now, I am at negative 13.5. So now I will go all the way to the other side, right? I'll keep moving until I reach somewhere maybe here. So now I am here at negative 13.5. Right? Okay, let me just make it a little bit longer. At 4 seconds now, I'm maybe somewhere here at negative 30. and at 5 seconds I am at here negative 37.5. So now I am moving here, right? Now I am at this at 5 seconds I am at negative 37.5. Right, now at 6 seconds, in fact the particle went back a little bit and now it is somewhere maybe here. So this point here, this is the negative 27 feet, right? So that's the path of the particle, right? So simply we need to find the distance. Simply I need to count. I need to just uh, find the absolute value for this. So now, for example, start from 0 here, then I went all the way to 10.5. So 10.5. So here let me write distance equal 10.5. Now notice that I went back to 0. So again another. I mean I went back from 0 to 0 from 10.5. So another 10.5. Right? Now I am here. Okay, now I'm going from 0, right, to 13.5. So I have traveled, we talk about the distance. So I have traveled additional plus 13.5. Now I'm here, right? Then now I went all the way to 30 feet. So I am here now. So how much we have covered this much, right? So it is plus 30 minus 13.5, right? We talk about, this distance between 13.5 and 30. So again, we talk about, that's the absolute sign. This is the amount, right? Now from 30 to 37.5, again I have plus 37.5 minus 30. This distance here, right? And now from 37.5 to 27. So I have plus 37.5, right? Minus 27. Now if you put this into the calculator, I got 69 feet. Okay, so that's the total distance traveled by the particle. The other way now to do this problem now is that we need to think about this. The velocity is the uh, derivative of the position, right? And let us do this for now. Let me just find the velocity. I'll tell you why. Now the velocity here will be ds over dt. So let me here write this is this is method 2. So method 2 equals, now let me find the derivative for that. I got 4.5 t squared minus 27t plus 22.5. If you want to know when this uh, function here, which is for the velocity, changes direction, right? We need to do the first derivative test, right? So again, this is already the first derivative. So now, in other words, now find where v is 0. At what time here? V here will be 0. So set the whole thing here to 0. So v here, I would have to say when this v equals 0. So now let us do this, because now see the following. That will tell us when the function changes direction, right? So from from positive to negative, negative to positive, and so on. So I have 4.5 t squared minus 27t plus 22.5 equals 0. Right? You can solve that in any method you prefer. Right? I'll just take 4.5 outside. So let's have t squared here. If you take 4.5 over 27 here, that's 6t, and here 22.5. If you take 4.5, you will leave with 5. Okay, equals 0. Now solve this simple equation, right? You get t equal 1 and t equal 5. So at these times, right, the particle changes direction, right? And now if you look at this, let us see now. we start from 0, right? We went to 10.5 to the right. Then now, see this. At t equal 1 second, in fact, we went back, right? So from 10.5 to 3 seconds now, I went back. Right now, we are still going back. At 5 seconds here, now see, at 5 seconds, I was at negative 37.5. Then now, I went to the right, and we found this, that at 6 seconds, in fact, the position was minus 27. So now, at these times, right, I can simply minimize my work and go back again to the position function here and substitute these times. So at x1, we have found, 10.5, and at x5, we have found negative 37.5, and we have already 5, right? We have already x at 6, right? Negative 27, and from here also we can conclude the same answer. We can just sum the distances, right? I hope you found this clear and helpful. If so, please support our work by sharing the video and liking, and don't hesitate to write any question and comment in the comment section. Thank you very much, and wishing you a good luck.